Okay, just going to go through a couple of questions today from what people have requested. So first one was question 4, lifts question. You've got this lift with two objects inside, 110 kilograms and 190 kilograms. The lift itself was a mass 1,700 kilograms and it's accelerating downwards 1.8 meters per second squared. For part A, you're asked to work out the tension in the cable. The best way to do this is to treat the lift and its objects as one particle. So we're going to resolve the entire lift plus its contents as one object. So, forces acting on the lift and its contents. Tension in the cable. The other thing is the mass or the weight of the lift and its contents, which would be all of the masses plus the mass of the lift added together times yg, so 2,000 g newtons, and that is it. There are no reaction forces or anything to think about because you're considering this as one single particle or one single object. So it's accelerating, so F equals ma. The mass of the lift and its contents is 2,000 times by the acceleration, which is 1.8, and the resultant force would be forces going with the motion, subtract the forces going against the motion, and make T the subject. And if you do that, I think you get 16,000 newtons. Okay, part B. Now you're asked to find the force exerted by box B on box A. So by box B on box A, so it's forces acting on box A. So resolve box A only. I'm going to draw a very quick sketch of box A. 110 kg, and it's in contact with the surface. And I'm going to label all of the forces acting on box A. 110 g, it has weight. Any other forces acting on box A, well, it's in contact with this surface or this object. So there's going to be a reaction force, I'll call it RA. And that reaction force is the force exerted by box B on box A, is that reaction force. And it is still accelerating downwards 1.8 meters per second squared. Okay, F equals ma. Mass of this object 110. Acceleration of this object is 1.8. Forces going with the motion. Subtract the forces going against the motion. And if you make RA the subject, you get 880 newtons. Part 2, the hardest part. So this time you want to work out the force exerted by box B on the floor of the lift, or on the lift. So there's two ways to do this, both give exactly the same answer. So the first thing is just consider the lift. So we're going to resolve the lift only. So the lift has a tension, which we worked out to be 16,000 newtons. The lift by itself has a weight, 1,700 newtons. 1,700 g newtons. And the lift is also in contact with an object, and that object will exert a force on the lift, and that force will point downwards, and we call that RB because that's from box B. Okay, those are the only forces acting on the lift. F equals ma. It's accelerating again downwards, 1.8 meters per second squared. The mass of the lift is 1,700. The acceleration of the lift is 1.8. the force is going down, 1,700 G plus the reaction force, subtract 16,000. And if you make RB the subject, then you get 2,400 newtons. And that would be resolving the lift only. The alternative is to consider object B only. Just resolve object B. Force is acting on object B. It has weight. It is in contact with a surface. However, it's also in contact with another surface from above. And this is the tricky bit. So A is going to exert a force on box B. And that force is not going to be the weight of A. It's going to be the same as the reaction force, which we worked out in part 1. This was the force that B exerts on A, and now we want the force that A exerts on B, and by Newton's third law, equal and opposite, that'd be 880 newtons. And those are the forces acting on box B. F equals ma. Remember, it's accelerating down. The mass of the object is 190. Acceleration of the object is 1.8. Forces going down would be 190 G plus 880, subtract RB. And if you made RB the subject, you get the same answer as above, 2,400 newtons. So those are the two ways to do part 2. But again, most of this question was just isolating one object at a time and go from there.